The wind cut sharp at 8,000 feet in the Rocky Mountains. Bjorn Hagen learned that his first winter in 1881, when ice formed inside his cabin walls and drafts blew snow through the gaps despite fresh chinking. He had built his cabin exactly like every other trapper in the territory was told to build it. Saddle-notched corners, mud and moss packed in the cracks, the standard frontier method that worked well enough. By spring, he had burned twice the firewood of his neighbors and still fought constant cold drafts. Within 3 years, he was re-chinking gaps every season like everyone else. Across the high country, trappers were losing the same battle against shrinking logs and failing chinking in cabins built by the book. Then Hagen quietly applied a traditional corner treatment from his Norwegian homeland that changed everything. What did he understand about log joints that kept his cabin sealed tight for 50 years without a single repair? The saddle notch method dominated frontier cabin construction for good reason. A trapper could carve the simple half-moon cuts in each log end within minutes using just an axe, creating a basic interlocking joint that held logs in rough alignment. Most settlers packed the inevitable gaps with whatever they could find: clay mixed with grass, moss stripped from nearby trees, or mud daubed thick between the courses. The technique required no special tools beyond what every frontiersman carried, no precise measuring, and no knowledge passed down through generations of craftsmen. Speed mattered more than perfection when winter threatened and supplies ran short. Across the valley, Hagen watched his neighbors follow this exact pattern through the autumn of 1881. Tom Morrison, a grizzled trapper from Missouri, notched and stacked his cabin walls in just 4 days, bragging that he would be trapping beaver while others still fussed with their buildings. The Hendricks family from Kansas packed their gaps with a mixture of local clay and dried grass, finishing their chinking in 2 long afternoons. Even the more methodical builders like Jacob Steiner took no more than a week to complete their walls, leaving time for hunting and gathering winter supplies before the snows arrived. By the following spring, the hidden costs of this frontier efficiency began to reveal themselves. Morrison's cabin developed a persistent draft along the north wall, where his logs had settled unevenly, creating gaps that no amount of additional chinking could permanently seal. The Hendricks family spent 3 days in March redaubing their walls after freeze-thaw cycles cracked their clay mixture, leaving finger-width openings that whistled with mountain wind. Steiner discovered that his carefully applied moss chinking had dried and shrunk over the winter, pulling away from the logs and creating gaps he had to stuff with fresh material every few weeks. The problem lay deeper than simple maintenance. Green, logs, cut fresh and stacked immediately, continued shrinking and settling for months after construction. The saddle notches, carved to fit snugly at first, gradually loosened as wood dried and compressed under the weight of upper courses. What began as tight joints slowly became loose connections held together mainly by gravity and hope. Chinking that had sealed perfectly. In autumn, cracked and fell out as logs shifted position, leaving openings that grew larger with each seasonal cycle. Hagen had arrived in the territory with knowledge that set him apart from his fellow trappers. Born in the timber country near Bergen, Norway, he had grown up watching his father and uncles build homes using techniques refined over centuries of harsh Scandinavian winters. Norwegian log construction, called laft in the old language, demanded that each log be individually fitted to the one below using careful scribing and hand carving. The process required patience, skill, and tools beyond a simple axe, but produced joints so tight that chinking became unnecessary. His father had taught him to use a marking compass, a simple tool with 2 metal points connected by an adjustable hinge. One point traced the contour of the lower log, while the other marked an exact matching curve on the log above. When carved to follow this scribed line, the upper log would rest in perfect contact with its neighbor, creating a compression joint that actually tightened as the wood dried and settled. The method took far longer than saddle notching, sometimes requiring hours to fit a single log properly. But Norwegian homes built this way had stood for generations without gaps or drafts. The other trappers in the valley watched Hagen's methodical approach with skepticism that quickly turned to mockery. Morrison stopped by one October afternoon to find Hagen carefully scribing the curve of his 7th log course, a process that had already consumed the better part of 2 days. You planning to carve furniture or build a cabin? Morrison asked, spitting tobacco juice into the dirt. Time you spent on that fancy notching, I could have chinked 3 cabins and been halfway to my trap lines. The Hendricks brothers shared Morrison's opinion, though they expressed it more diplomatically. Mr. Hagen's got the right idea about being thorough, the elder brother told his wife within Hagen's hearing, but a man can overthink a simple shelter. These mountains don't care how pretty your joints look when the snow starts flying. Even Steiner, despite his own attention to detail, questioned the Norwegian's approach. I admire careful work, he told Hagen during a brief visit, but winter won't wait for perfect corners. Sometimes good enough has to be good enough. The general consensus among the valley's trappers held that Hagen was wasting precious time on unnecessary refinements that served no practical purpose. Hagen understood their criticism, but had seen too many chinked cabins fail in Norway's demanding climate to trust such methods in the Rockies. Norwegian winters brought sustained cold that could crack poorly sealed joints, creating drafts that made cabins uninhabitable despite thick walls. American frontier construction might work adequately for temporary shelters, but Hagen intended to build a home that would serve him for decades, not merely survive a single season. The conflict represented more than different building techniques. Frontier culture prized speed, adaptability, and making do with available resources, while traditional craftsmanship demanded time, precision, and respect for proven methods. Most American settlers viewed their first cabins as temporary structures to be improved or replaced as circumstances allowed. Hagen approached his construction as a permanent investment that would either succeed completely or fail expensively. As autumn progressed toward winter, the philosophical divide became practical reality. While his neighbors finished their cabins and began their trap lines, Hagen continued his meticulous process, scribing and carving each log to achieve perfect contact with its neighbors. The method consumed weeks rather than days, but produced corners with no visible gaps, even before chinking. Whether this traditional Norwegian approach would prove superior to accepted frontier wisdom remained to be tested by the brutal mountain winter ahead. The emerging conflict would be settled not by opinions or traditions, but by measurable results: warmth, fuel consumption, maintenance requirements, and long-term durability. Both methods would face the same harsh conditions, but only one would prove worthy of the mountain environment's unforgiving demands. Most frontier cabins began with the simplest possible foundation, logs laid directly on cleared ground. The method required no additional materials, no specialized knowledge, and no extra time beyond leveling the site with an axe and shovel. Trappers and settlers simply felled trees of roughly equal diameter, squared the building area by pacing off dimensions, and began stacking walls immediately on the forest floor. The approach worked adequately for temporary shelters, but revealed serious flaws as seasons passed and ground conditions changed. Hagen recognized the foundation problem from his childhood observations in Norway's wet climate. His father had built their family home on flat fieldstone piers that lifted the sill logs 8 inches above grade, protecting the wood from ground moisture and providing drainage during spring snowmelt. Norwegian builders understood that direct soil contact invited rot, insect damage, and uneven settling that could distort an entire structure over time. The mountain valleys of Colorado presented similar challenges: heavy winter snow, spring runoff, and freeze-thaw cycles that could saturate soil and shift poorly supported foundations. While his neighbors rushed to begin wall construction, Hagen spent 5 days preparing his foundation with methodical care. He selected 12 flat sandstone slabs from a nearby outcrop, each measuring roughly 18 inches square and 4 inches thick. The stones had weathered naturally into relatively level surfaces that required minimal shaping with hammer and chisel. He arranged these foundation stones in 3 parallel rows beneath where his sill logs would rest, spacing them at 4-foot intervals to distribute the cabin's weight evenly across the building footprint. The foundation layout followed principles his uncle had taught him during a barn raising near Bergen. Load-bearing stones must sit level with each other to prevent differential settling, and they must extend beyond the log width to provide stable bearing surface. Hagen used a water level, a simple device made from leather tubing filled with water, to ensure all 12 stones sat at exactly the same height. When water in both ends of the tubing showed equal levels, he knew the stones were perfectly aligned, preventing any tendency for the cabin to tilt or sag unevenly. Log selection proved equally critical to long-term stability. Most trappers simply used whatever trees grew closest to their building site, accepting knots, curves, and variations in diameter as unavoidable characteristics of wilderness construction. Hagen walked the valley for 2 weeks, marking only those pines that met his exacting standards. Straight grain with minimal taper, diameter between 12 and 14 inches, measured 6 feet from the butt end, and freedom from large knots that could create weak points or drying cracks. He rejected nearly 3 trees for every one he selected. Twisted grain, even slight spiraling that most builders would ignore, could cause a log to warp severely as it dried, potentially breaking the tight joints he intended to create. Excessive taper meant that logs would not stack evenly, creating gaps that would widen over time. Large knots weakened the wood and often dried at different rates than surrounding timber, causing splits that could compromise structural integrity. Norwegian log builders had developed these selection criteria over centuries of experience with timber that must perform reliably for generations. The felling and preparation process reflected equal attention to wood quality. Hagen cut his trees during late autumn when sap flow had stopped, reducing the moisture content and minimizing future shrinkage. He limbed each tree immediately to prevent bark beetles from boring into the wood, then peeled the bark completely to expose any hidden defects before transport. Trees with insect damage, hidden rot, or internal checking went into his firewood pile rather than his wall logs. Each log received careful preparation before placement. Hagen used a draw knife to smooth rough spots and remove protruding knot stubs that could prevent tight stacking. He checked every log for straightness using a taut string line, rejecting any piece that deviated more than half an inch over its 15-foot length. The most critical step involved orienting each log properly. The natural crown, or slight upward curve present in most trees, must face upward to counteract the downward deflection that would occur under load from upper courses. The first winter exposed fundamental differences between foundation approaches. Morrison's cabin, built directly on grade, experienced immediate problems when autumn rain saturated the soil beneath his sill logs. The wood absorbed moisture through direct ground contact, causing the lower courses to swell and then compress as winter cold froze the saturated timber. By February, his cabin had settled nearly 2 inches on the south side where runoff from the roof had created persistent wet conditions. The Hendricks family faced similar settling problems, complicated by their choice of foundation logs with excessive taper. Their building slowly tilted as the smaller ends of their sill logs compressed more than the larger ends, creating a noticeable slope that made their door difficult to close properly. The uneven settling opened gaps in their chinking and created stress points in their wall logs that eventually led to splitting. Steiner had laid his cabin on reasonably level ground with well-matched logs, but direct soil contact still caused problems. Spring snowmelt in 1882 created standing water around his foundation for nearly 3 weeks, soaking the bottom logs and creating ideal conditions for wood-rotting fungi. By summer, he could push his knife blade easily into the softened wood, and he began planning to replace his entire bottom course before the next winter. Hagen's stone pier foundation avoided these problems completely. The raised sills allowed air circulation beneath the cabin, preventing moisture accumulation and maintaining dry conditions around the wood. Spring runoff flowed freely under the building without contacting the logs, while the stone piers provided stable, non-compressible support that could not settle or shift with changing ground conditions. The careful log selection meant that his courses remained straight and true as the wood seasoned, maintaining the precise fits he had carved between each piece. The foundation strategy proved its worth through measurable results. After 18 months, surveys using a simple plumb line showed that Hagen's cabin remained perfectly level, while his neighbors' buildings had developed noticeable tilts ranging from 1 to 3 inches over their 12-foot widths. The raised foundation had cost extra time and effort during construction, but eliminated the settling problems that plagued ground-level cabins throughout their service lives. More importantly, The stable foundation preserved the integrity of Hagen's carefully crafted corner joints, allowing his compression fit notching system to function as designed rather than loosening due to structural movement. The marking. Compass represented the essential difference between Norwegian and American log construction. This simple tool consisted of two sharp metal points connected by an adjustable brass hinge, allowing the user to maintain a consistent distance while one point traced an irregular surface and the other marked a corresponding line. American saddle notch builders had no use for such precision, relying instead on eyeballing rough cuts that would be filled with chinking anyway. Hagen's compass, inherited from his father's toolbox, enabled him to create joints that matched the exact contours of each log, rather than settling for approximate fits. The scribing process began with positioning each new log in its intended final location atop the wall. Hagen used wooden skids and rope tackle to roll heavy logs into place, then secured them with temporary wooden wedges to prevent shifting during the marking process. With the log held firmly in position, he adjusted his compass to span the widest gap between the new log and the one beneath it, typically measuring between 2 and 3 inches for logs of slightly different diameters. Walking the length of the log, Hagen held one compass point against the lower log surface, while the upper point traced a corresponding line on the log above. The technique required steady hands and careful attention, as any variation in compass width or deviation from the lower log's contour would create imperfect fits. Norwegian craftsmen called this process scribing the log to the bed, meaning that each piece was individually fitted to match its specific resting place, rather than cut to some theoretical standard dimension. The carved notch extended far beyond the simple corner treatments most Americans knew. While saddle notches created contact at just 2 small points, where the upper log rested on curved shoulders, Hagen's full scribe method produced contact along the entire length where logs met. His draw knife and curved adze removed wood in thin shavings, following the scribed line to create a concave surface that matched the convex curve of the log beneath. The process consumed hours per log, but resulted in joints where nearly every square inch of adjacent wood surfaces touched. Critical to the system's success was carving the notch slightly tighter than the scribed line indicated. Hagen deliberately removed less wood than his compass mark suggested, creating a notch perhaps 1/8 inch smaller than the log it would receive. This forced him to drive each log into place using a wooden maul and blocking, compressing the wood fibers, and creating mechanical pressure at the joint. The technique required judgment born of experience. Too loose and gaps would appear as wood dried, too tight, and the logs might split under the pressure needed to seat them properly. The compression principle worked because wood behaves as a slightly elastic material when subjected to moderate pressure. The tight fit deformed both logs slightly at their contact surfaces, creating continuous pressure that held the joint together and sealed against air infiltration. As the wood seasoned and shrank over subsequent months, this compression actually increased rather than loosened, tightening the seal progressively over time. Hagen's corner treatment differed fundamentally from his neighbor's approaches in the geometry of load transfer. Saddle notches concentrated all the weight of upper logs onto 2 narrow bearing points, creating high stress that gradually crushed the wood fibers and allowed settling. Full scribe joints distributed the same loads across much larger contact areas, reducing stress and preventing the compression that caused saddle-notched corners to loosen over time. The tool requirements extended beyond the compass to include specialized Norwegian woodworking implements rarely seen on the American frontier. His curved adze, forged with a blade bent at precisely 20 degrees, allowed him to hollow out the concave notch surfaces efficiently while maintaining control over the cutting depth. A set of wooden-handled carving gouges enabled fine-tuning of the fit, removing small amounts of wood where the scribe marks indicated high spots that prevented perfect contact. During the second winter, the performance differences between joinery methods became unmistakable. Morrison visited Hagen's cabin during a February blizzard and found the interior remarkably free of drafts, despite wind that rattled his own poorly sealed walls. Testing with a candle flame, Morrison could detect no air movement at Hagen's corners, even when the wind gusted to what he estimated at 40 miles per hour outside. The same test at his own cabin revealed multiple locations where the flame flickered violently, indicating significant air infiltration through loosened chinking and settling joints. The Hendricks brothers faced even worse sealing problems as their cabin's foundation settling created stress that pulled their corner joints apart. Gaps wide enough to admit a finger appeared at several corners by spring, requiring extensive rechinking that lasted only until the next settling cycle loosened the repairs. Their fuel consumption increased dramatically as heated air escaped through the widening cracks faster than their fireplace could replace it. Steiner's more carefully built cabin performed better than his neighbors, but still required annual maintenance to address settling and shrinkage gaps. His detailed records showed that he spent approximately 12 days each year rechinking various joints, consuming nearly half a quart of clay and moss in the process. The work became increasingly difficult as settling created irregular gap patterns that resisted permanent sealing. Hagen's cabin required no chinking maintenance whatsoever. The compression joints remained tight through 3 complete seasonal cycles, showing no visible gaps even when inspected with strong lamplight from inside during windstorms. The wood-to-wood contact created by his full scribe technique provided inherent sealing that actually improved with age as the compressed fibers adapted to their new positions. By the 3rd spring, neighboring trappers began requesting demonstrations of Hagen's technique. Several watched him scribe and fit logs for a small addition to his cabin, noting how the process consumed far more time than their familiar methods, but produced joints of remarkable precision. Few possessed the specialized tools or developed the hand skills needed to replicate his results, but most acknowledged the superiority of his approach for permanent construction. The economic implications extended beyond initial construction time to long-term maintenance costs. Hagen's higher labor investment during building eliminated the recurring expenses his neighbors faced for chinking materials and annual repair work. Over 5 years, his neighbors collectively spent more than 60 days on maintenance that Hagen's cabin never required, while also consuming substantial quantities of clay, moss, and other sealing materials that must be gathered and processed each season. The full scribe technique had proven its worth through measurable performance advantages that grew more pronounced with each passing year, establishing compression-fit joinery as demonstrably superior to saddle-notch construction for permanent frontier housing. Green timber presented challenges that most frontier builders ignored until problems appeared months or years after construction. Freshly cut pine contained roughly 40 to 50% moisture by weight, water that would gradually evaporate over the following seasons regardless of construction method. As this moisture escaped, logs shrank both in diameter and length, with the greatest dimensional change occurring perpendicular to the grain direction. Norwegian builders had long recognized this inevitable process and developed techniques to harness shrinkage rather than fight it. Hagen's father had taught him to monitor wood movement through what Norwegian craftsmen called the settling year, the 12-month period when most dimensional change occurred in newly constructed log buildings. The process required periodic inspection and selective adjustments to maintain structural integrity as individual logs found their final dimensions. American frontier builders typically ignored settling completely, allowing cabins to distort naturally and then addressing problems with additional chinking or crude repairs. The key insight involved predicting shrinkage patterns and pre-compensating for them during initial construction. Pine logs typically lost 6 to 8% of their diameter during the first year of drying, with most change occurring during the warm months when evaporation rates peaked. Hagen carved his compression joints anticipating this shrinkage, making notches that would become even tighter as the wood dried rather than loosening like conventional joints that started with barely adequate fits. Seasonal inspection began each spring when warming temperatures accelerated moisture loss from the cabin's logs. Hagen walked the perimeter of his building with a thin-bladed knife, probing joints for any signs of loosening or gap formation. The technique required intimate knowledge of how each individual log had been positioned, as settling rarely occurred uniformly across an entire wall. Logs with more initial moisture content, higher positions in the wall, or exposure to prevailing winds dried at different rates and required individual attention. During the second spring after construction, Hagen discovered that one log on his south wall had developed a hairline crack along its upper surface, where differential drying had created internal stress. Rather than accepting this defect as inevitable, he removed the affected log completely, replaced it with a backup piece from his construction surplus, and rescribed the joint to maintain perfect contact. The repair consumed 2 days of labor but prevented a weakness that could have compromised the wall's integrity for decades. The monitoring process revealed patterns invisible to casual observation. Logs on the south and west walls exposed to maximum solar heating dried faster than those on the north side, where snow lingered longer and temperatures remained cooler. Upper courses, with better ventilation and less weight compression, showed more shrinkage than lower logs that were compressed by the load of courses above them. End-grain surfaces at door and window openings lost moisture more rapidly than the sealed log sides, creating potential stress points that required attention. Hagen developed a systematic approach to managing these variations. Each autumn, before winter cold slowed the drying process, he inspected every joint and made minor adjustments where needed. Some logs required gentle tapping downward to close small gaps that had opened during the summer drying season. Others needed slight repositioning to relieve stress concentrations that could lead to splitting. The work rarely consumed more than 2 days annually, but prevented the cumulative distortions that plagued neighboring cabins. Species selection proved equally important for long-term stability. The valley's forests offered several conifer options, but Hagen chose exclusively lodgepole pine for its moderate shrinkage, characteristics, and predictable drying behavior. Engelmann spruce, while abundant, tended to warp more severely during seasoning. Douglas fir, despite its strength, showed higher shrinkage rates that could stress his tight-fitting joints beyond their capacity. Lodgepole pine provided the optimal balance of workability, stability, and availability for precision log construction. The wood's grain orientation within each log significantly influenced shrinkage patterns. Hagen positioned every log with careful attention to its growth characteristics, placing the original tree's crown side upward, where the natural curve would counteract sagging under load. More importantly, he oriented logs so that any tendency to warp or twist during drying would work with, rather than against, the building's structural requirements. Logs that might crack or check during seasoning were positioned where such defects would not compromise joint integrity. By the 5th year after construction, the cabin's logs had reached equilibrium moisture content with the mountain environment, ending the active settling period. Measurements taken with calipers showed that individual logs had lost between 1 and 1/2 inches in diameter, exactly within the range Hagen had anticipated when carving his original joints. The compression-fit notches had accommodated this shrinkage by becoming progressively tighter, maintaining complete contact as the wood dimensionally stabilized. The long-term results contradicted conventional wisdom about log construction durability. Morrison's cabin, now showing significant deterioration from uncontrolled settling and moisture infiltration, required major repairs, including replacement of several rotted lower courses. The Hendricks family had abandoned their original cabin entirely, building a new structure using conventional frame construction after their log building became uninhabitable due to accumulated settling damage and chronic air leakage. Steiner maintained his cabin through persistent maintenance, but his detailed records documented the escalating costs of fighting natural wood movement rather than accommodating it. By the 5th year, he had replaced 4 logs that split from uncontrolled drying stress, re-chinked his walls 7 times, and spent 36 days on various repairs needed to keep the building weatherproof. His annual maintenance requirements actually increased over time as initial problems created cascading damage that demanded progressively more extensive fixes. Hagen's approach produced opposite results. After 5 complete seasonal cycles, his cabin required no structural repairs and showed no signs of the deterioration affecting neighboring buildings. The logs had settled into their final positions, with joints that remained gap-free even during severe weather conditions. Inspection with bright lamplight on windy nights revealed no air infiltration points, while temperature measurements showed minimal heat loss compared to conventional chinking-dependent construction. The Norwegian method's success lay not in preventing natural wood behavior, but in understanding and accommodating it through superior initial construction and systematic maintenance. By anticipating shrinkage, monitoring seasonal changes, and making small corrections before problems escalated, Hagen had created a building that actually improved with age rather than deteriorating like conventional frontier construction. The economic implications became clear when neighboring trappers calculated their cumulative maintenance costs against Hagen's minimal annual inspection time, establishing compression-fit construction as not merely superior craftsmanship, but sound long-term investment in permanent frontier housing. The winter of 1932 brought conditions that tested every structure in the valley beyond normal endurance. Snow accumulated to depths exceeding 8 feet by January, creating loads that stressed roof systems and wall joints far beyond typical seasonal pressures. February delivered alternating cycles of warming and hard freezing that expanded and contracted building materials in ways that revealed every weakness in aging construction. March brought unprecedented rainfall on top of the existing snowpack, creating runoff volumes that saturated soils and flooded basements throughout the region. Thermal cycling during this extreme weather sequence exposed fundamental differences between construction methods that had remained hidden during milder seasons. Rapid temperature swings from 20 degrees below zero to 40 degrees above, sometimes occurring within 24-hour periods, caused dramatic expansion and contraction in building materials. Chinked log cabins faced particular stress as their mixed materials, wood, clay, moss, and stone, expanded and contracted at different rates, creating shear forces that tore apart previously stable joints. Morrison's cabin, now 51 years old, suffered catastrophic failure during the March thaw. The combination of heavy snow loading and saturated foundation soils caused his entire north wall to lean outward by nearly 6 inches, opening gaps at the corners wide enough to throw a cat through. Meltwater poured through the compromised joints, soaking his interior and ruining stored supplies. By April, the building was uninhabitable, forcing Morrison to construct emergency shelter from salvaged materials while planning complete reconstruction. The Steiner family cabin demonstrated how accumulated maintenance problems compounded under extreme stress. Decades of re-chinking had created a patchwork of different materials with varying expansion coefficients. Clay patches contracted more than wood during cold snaps, while moss insulation compressed differently than mud daubing when saturated. The thermal cycling opened new gaps faster than repairs could be made, creating a feedback loop where each temperature swing worsened existing problems and created additional failure points. Measurement techniques available by the 1930s allowed precise documentation of structural performance that earlier generations could only estimate. A surveyor working for the county road department used a transit and measuring chain to document foundation movements and wall deflections in the valley's older buildings. His records showed settlement and tilting that ranged from 3 inches to more than a foot in cabins built with conventional methods, with most movement occurring during the extreme weather cycles of that winter. Hagen's cabin, now past its 50th birthday, showed measurable superiority in every category the surveyor examined. Foundation settlement measured less than half an inch over 5 decades, compared to 8 to 12 inches for neighboring structures built the same year. Wall plumbness deviated less than 1 inch from vertical, while conventional cabins showed lean angles of up to 4 degrees from true. Most significantly, joint integrity remained intact throughout the structure, with no detectable air infiltration even when tested with smoke sticks during high wind conditions. The thermal performance advantage became quantifiable through fuel consumption measurements that several families began tracking during the harsh winter. Hagen's nephew, visiting from Denver, recorded daily wood consumption and interior temperatures using a reliable thermometer and careful log-keeping methods. Despite the cabin's age, it maintained comfortable interior temperatures of 65 to 70 degrees Fahrenheit, while consuming only 2 1/4 cords of firewood through the entire winter season. Neighboring families with conventional construction burned between 4 and 6 cords during the same period while achieving interior temperatures 10 to 15 degrees lower than Hagen's cabin. The difference reflected not just air sealing, but thermal mass effects from the tight-fitted log walls, which absorbed heat during the day and released it slowly at night, moderating temperature swings that plagued poorly sealed buildings. Heat loss calculations showed that draft infiltration in chinked cabins wasted approximately 60% of generated heat energy. Documentation of the Norwegian method began attracting attention from building professionals in Denver and Colorado Springs who were developing mountain resort properties for wealthy clients. A timber contractor named James Sullivan visited the valley specifically to examine Hagen's construction techniques after hearing reports about the cabin's exceptional durability. Sullivan spent 3 days measuring joint details, photographing construction features, and interviewing local residents about long-term performance comparisons. Sullivan's visit marked the beginning of formal knowledge transfer from immigrant craft traditions to professional construction practice. He documented Hagen's scribing and compression fit techniques in detailed drawings and written specifications that he later used for high-end lodge construction in mountain resort areas. The precision joinery methods, previously dismissed as unnecessary refinement, gained recognition as cost-effective approaches for permanent mountain construction where maintenance access was difficult and heating costs were significant concerns. Younger builders in the valley began seeking instruction in the Norwegian methods during the summer of 1933. 2. Homesteaders planning new cabins asked Hagen to demonstrate proper scribing techniques and supervise their corner construction. Both men possessed basic carpentry skills but lacked experience with the specialized tools and precise fitting required for compression joints. Hagen spent several weeks teaching them proper compass use, draw knife techniques, and the critical judgment needed to achieve tight fits without splitting logs during assembly. The knowledge transfer process revealed how traditional craft skills depended on subtle techniques that could not be learned from written descriptions alone: hand coordination for maintaining consistent compass pressure while scribing, recognition of wood grain patterns that indicated splitting tendencies, and development of the precise touch needed for final fitting required extended practice under experienced supervision. Written manuals could document procedures, but master craftsmen were essential for transmitting the tacit knowledge that made complex techniques reliable in field conditions. By 1935, 4 new cabins in the valley incorporated full scribe Norwegian joinery methods with varying degrees of success. The builders who had received direct instruction from Hagen achieved results approaching his standards, while those attempting to work from written descriptions alone struggled with joint consistency and long-term performance. The experience demonstrated that traditional craft knowledge required human transmission chains to survive transitions between generations and geographic locations. Documentation efforts expanded when the Civilian Conservation Corps began surveying historic construction techniques as part of their national forest building programs. Government architects recognized that traditional methods often provided superior performance for backcountry construction where modern materials and maintenance were impractical. Hagen's cabin became a case study in their technical manuals, with detailed drawings and performance specifications that influenced federal building standards for remote forestry facilities. The legacy extended beyond individual buildings to influence entire regional construction practices. By 1940, mountain builders throughout Colorado had adopted modified versions of Norwegian scribing techniques, though few achieved the precision of traditional craftsmen. The methods became known as Scandinavian joinery in construction circles, acknowledging their immigrant origins while adapting them to American materials and building codes. 50 years after construction, Hagen's cabin stood as proof that superior craftsmanship could triumph over expedient methods, establishing traditional knowledge as valuable engineering information rather than obsolete folklore.